Local variable scope. Here we have two functions f and g that both take the same named parameter x. However, those variables are local, and what that means is that they are different from each other. Each function has its own set of local variables that have nothing to do with any other function's local variables. So even though this looks like it's x and that is x, and it looks like maybe they're the same variable, they're not. They're completely different x's, and they can each hold a value at the same time. They can hold different values. To see that, it's best if we visualize the execution here. So in visualizing the execution, we see that we define f, we define g, and now we're calling g of 2. When we do that, we get to this line of code, and here in g, x equals 2. So far, so good. Inside g, we're going to call f of, well, x times 2. So f of 4. We go here, and off we go. Now in f, x is 4. But look over here. There are two function calls going on right now. Sure, we're inside f, and x is 4, but we're still inside g, which called f, and in g's x equals 2. This picture makes this very clear. There are two completely different x's here. They have nothing to do with each other. So now as I step through f, it'll say in f, x is 4 because f's x is 4. It adds 5 to x, which sets it to 9. Which x? F's x. Got 4 added to it. G's x isn't involved here at all because G's x is local to G, and we're in f right now. 9 gets returned. Now G called f again with x times 3. Which x? Well, when you're in G, you always use G's x. That's 2, hence this is 6. Back here of f of 6, and we're in f with x equals 6. We add 5 to f's x to get 11 and return 11. Now G took that 11 and added it to the 9 from before to get its return value of 20, which is what gets printed. So again, local variables can have the same name, and it doesn't matter because they are in fact different variables.